So welcome back to part 2 of this. I'm going to show work here. This is actually not how the book tells us to do it. They normally just tell us this column and then the Y and then the ordered pair. I like to put the work in there so that I can see if I've made a mistake. It's very easy for me to go back and spot where I made it. So I'm going to go ahead and go through the process here. One thing that I recommend is that you spend some time thinking before you jump into doing the actual work. And that moment of thinking can really help you out, make your life a lot easier. So if you take a look here, I started off with, where's my pen? Started off with this. I have the 3x minus 5y equals negative 10. I wanted to get this so that it says y equals, so I went ahead and moved that 3 over to the other side, became a negative 3x, and then I divided by that negative 5, and so this became y equals 3/5 x plus 2. Now, I don't know about you, but I'm not a fan of working with fractions, especially if I have to try graphing them. So I want to do something that's going to help me out. And what I'm going to do is I'm going to use a multiple of 5 so that this will cancel out. Okay, so as it is, I picked negative 5, 0, and 5. All right, that is by design. I could have used 0, 5, 10, or anything along that line so that it will help me cancel out. So let's go ahead, and I actually want to go ahead and do this work here. So we're going to take our 3/5 times a negative 5 plus 2. All right, and so this 5 and this 5 are going to cancel out. So now I'm going to have a negative 3 times 1, or 3 times negative 1, plus 2. And so that's going to be a negative 3 minus 3 plus 2 is going to give me a negative 1. So my ordered pair here is going to be negative 5, negative 1. All right. Same concept on the next one. I'm going to use a number that's really convenient. 0 is almost always convenient. If they haven't given you the y-intercept already, this is a really good way to make certain that you're getting an easy problem. So I'm going to plug in a 0 for my x. So I'm going to have 3/5 times 0 plus 2. Well, that of course is going to just become a 2. Right? So I have 2 here, and I have a 0, 2. And here I have my 5. Again, I'm going to go ahead and multiply that. My 3 over 5 multiplied by 5. So again, this one and this one are going to cancel out to give me a 1. So that's going to become a 3. 3 times a 1, right? And then I have my plus 2. So 3 times 1 is a 3. Plus my 2 gives me a 5. All right, so this is going to give me 5 here. And again, I want to reiterate that this is y or f of x, or the function that depends upon x. These are exactly the same thing. This is not a multiplication problem. I want to make certain we're real clear on that. And then here my point is going to be 5, 5. All right, so I'm going to scroll down a bit, and I'm going to, just for my own convenience, because I know that my graph is further down, I'm going to go ahead and rewrite this. So I've got my negative 5, negative 1. Not sure why those negatives keeps wanting to escape, but they are definitely trying to. So I'm going to have a 0, 2, and I'm going to have 5, 5. And before I go too much further, I want to point out one thing. So here to here, we went up 5. And from here to here, we went up 5. From here, for my f of x, -1 to 2 is a +3. And from 2 to 5 is going to be a +3. Take a look at that. 3/5, right? So that 3 over, if I were to figure it out for one individual problem, like if this was instead of a 5, I wanted it to be a 1, I'm going to have that 3 over 5. And the fact that this is right here, and this is what we get when we do this work, it is not an accident. We will talk a lot more about that. It's called slope. I want to make certain that you guys are aware that it exists. All right, so I'm going to go ahead and plot this. I've got my -5. There's my marker. Okay, so I'm going to call that -5. Right, there's my -5, and 1. There's my -1. So I'm going to have that right there. Come on. Why are you not doing what you're supposed to? There we go. All right, and then I have 0, 2. So I'm on my 0, 1, and 2. Okay. And then I'm 5, 5. I've got 5, 5. Right about there. And as you can see, we have a line running right through those, right? You can see that that's shaping up to be a line. Okay, those 3 dots. Now, I want to point out one thing. If I had made a mistake, okay, and I'm going to change this color so that we are real clear that this is an intentional mistake, and we're just trying to make a point here. I'm going to say, let's say I said -5 and 3. Well, if I did that, I would have a point. I would have -5 and then 1, 2, 3. Now, if you take a look, this goes into kind of like this V shape, and that should tell you right away that there's a mistake somewhere. Now, you don't know immediately that it was this one, right? You would have to go back and check your work, which is one of the reasons why I like doing it this way. But I want to make sure that we're clear on the fact that just because the first one, this first one reading left to right, this may not be the incorrect one. In this case it is, but you need to double check until you get them all correct so that they all are in a nice line like this. Okay? Let's move along. Here is a case where we have values that are not, we're not using them in a way to make a linear function, okay? This has an exponent on it. If you look at every single one that we've done so far, right, every one of our equations, we have no exponents other than 1, right? We don't normally write the 1. So we have no exponents on here, on this one, and we don't have any exponents on these guys either, right? So this is all exponents of 1. So with that in mind, the moment we get an exponent other than 1, right, here we have a 2, all of a sudden we no longer have a line. We have some other thing happening, all right? And in this case, it's going to wind up being a quadratic function, and it will have a parabola shape. And I want to make sure that we kind of are clear on a couple of things here. First of all, this exponent, right? This tells me, where am I? Oh, there I am. Okay, so this exponent tells me the maximum number of possible solutions. And when I say that, I mean that there is only 2 possible solutions. You can't have 3, you can't have 5, you can have 0, 1, or 2. All right, those are your only options. Now, it's possible to have less than 2. It's possible to have the 0. It's possible to have the 1. But I want to make sure that we all know that this is the maximum number of possible solutions. Also, if you take this value minus 1, it will tell you how many times the function can bend. Now, it doesn't always have to bend like that, but it will tell you the maximum number of times it can bend. In this case, we're going to have 1 bend because I have a 2 minus 1 is going to leave me with a 1. All right, I'm going to go ahead and see if I can get some of this done. I'm going to use a negative 1 squared minus 9 times negative 1 minus 12. So that's going to become a 1 plus a 9 minus 12, right? So that means I'm going to have a negative 2. All right, so this is going to be negative 1, negative 2. All right, for 0, this one's again a super easy one, right? I want to have 0 squared minus 9 times 0. I'm going to just leave those all off, right? So I'm going to have a negative 12 as my answer because everything else went to 0. So negative 12, and my coordinate point is 0, negative 12. All right, so I have a 2. All right, my 2 right here. I'm going to go ahead and plug that value in. So I've got a 2 squared minus 9 times 2 minus 12. And that's going to equal 16 minus 18 minus 12. All right, so if I do my 16 and I subtract 18, that leaves me with a negative 2, so I'm going to have a negative 14. Here is my answer. So 2, negative 14. Here I'm going to do my 4, so I have a 4 squared minus 9 times 4, and I'm going to have a minus 12, so that's going to get me 16 minus 18, no, minus 36, my bad. So minus 36 minus 12. Well, my 16 minus 36, that's going to get me a negative 20. So negative 20 and negative 12 is going to be negative 32. All right. So here I'm going to have a 4, negative 32 is going to be that number. I'm going to go ahead and do my 5. We're going to run through them all, and I realize I'm getting long on this, so I probably will have to do a third one, but I would rather spend that little extra time so that you've got it and it makes sense. So here I have 25 minus, and I've got 45 minus 12. So this is going to leave me with a negative 20 and a negative 12. So I'm going to have a negative 32 again. I think I did that right. 25 minus 45, that's negative 20. And yeah, okay. I just wanted to double check that I got it right. All right, so here I'm going to have my 10 squared minus 9 times 10 minus 12. All right, so I'm going to have 100 minus 90 minus 12. So that's going to give me a negative 2, right? Because I have here to here, I have a positive 10 yet, and then I take away the 12, that leaves me with a negative 2. 10 minus 2, that's my coordinate point. Here I have 12. Let's go ahead and do that. I'm going to do 12 squared minus 9 times 12 minus 12. Where did my one? There's go. Minus 12. All right. So I'm going to point out one thing, and this is just kind of how my brain works. I look for ways to group things into tens, just because they're easier. So here I have a 9 times 12, and then I have another 12, and those are both negative. So this is going to become this. It's the same as if I have 10 times 12. So I'm going to have 144 minus 120, which is going to leave me with a positive of 24. So I have 24 here. So 12, 24. All right. So clearly this is not going up at the same pacing. It seems really like, wait a minute, what just happened here? So there's a lot of change happening. Like from here to here, we have a shift of 2, right? Where'd my pen go? There we go. All right. So from here to here, we have a shift of 2. We're going up by 2. And the difference here to here, right? Instead of it goes up to 24 to negative 2, that's going to be a decrease of 26. But from here to, from here to here, again, I have a 2. And from here to here, I have a 2, right? So if I go from here to here, I go from negative 12 to negative 14, that's going to be a 2. And then I go from 14 to 32, negative 14 to negative 32. That's going to leave me with, it's going to be 18, if I'm doing my math right. So it's going to be a negative, that's a negative 2 because it's going down. This is also going to be a negative. And then all of a sudden, here, I'm going up, right? So from here to here, again, I have a 2, but from here to here, I have a positive 26. All right? I have a positive 26. So if you look, this thing is kind of has a pattern here, this negative 26 and the positive 26. Here I have a value that's a 12, 14, then I have 32 and 32, and then I have the 2 up here, right? Here's a 2 again, and then I have the 24 and the 24. So something's happening here that's not what we would expect from a line. And in fact, what we have is called a parabola. And it's this symmetrical shape. Again, remember we have an exponent of 2, so there's a possibility of 2 solutions. There doesn't have to be 2 solutions, but it can't be any more than 2. If you take a look, there's only one place that this bends, and that's right here, which is what we would expect since it's 2 minus 1 would give us the number of times it can bend. And our actual real number solution, right, we call the real solutions because it falls on the real number line, is going to be 1 here and 1 here. Okay, those are my real solutions. All right, I'm going to call this good enough, and hopefully I didn't go too long. Distance formula and the rest we're going to pick up on day 2.